Hey, let me get a 2x4 by 18 inches over here.
You got it, boss. God dang, this takes forever.
Hey, this piece is too short. There's gotta be a better way.
Hi, I'm Nguyen, and I'm here with our team to save your fingers, your lumber, and your houses with our automatic modular miter saw system.
Once the board is securely clamped, the cut can be made. To actuate the saw blade, a winch mechanism was chosen. A cord would be secured to this peg and wrapped around the winch's pulley. To cut, the winch will reel in the cord and bring the saw blade down. Once the cut is complete, the winch will unspool and the spring inside the saw's pivot will bring the blade back up. Our team decided the best way to fit the winch mechanism and mount the vertical clamping piston was to create a replacement fence for the saw which would integrate these features. The fence is the vertical backing piece which the wood is pushed up against to assure it is perpendicular to the saw blade. This style of actuation mechanism was chosen as it requires minimal modification to the existing saw.
Once the board has been ejected from the magazine, it slides onto the automated conveyor system. This system uses a lineup of precision idler rollers and 4 powered rollers driven by high-accuracy stepper motors. As the board is moved towards the blade, a guide directs the board to the back of the conveyor to ensure it is aligned with the saw. To make sure nothing slips or shifts, an extra roller has been added to the top of the board to ensure an accurate measurement as it slides towards the cutting wheel. This ensures a firm, reliable grip and an accurate measurement right before cutting.
Pusher system is designed to dispense at most 15 planks of wood. The main part is the magazine, which has an extruded cut on the bottom in order to push wood out of the system into the roller system. The magazine has a sliding door for loading the system with wood and an open top for ease of maintenance. There are 3 pistons that sit in order to push the aluminum pipe back and forth, dispensing the wood. The mounts and the piston are derived from McMaster-Carr.
This is our clamp for our saw system. Here in the front, you can see there is a hole where the piston will actually sit in place. There's even a cut here in the metal to bend outward so the piston can slide through and to be able to be compressed using a screw through the top. Over in the front, you can see that there is some slotting where an actual handle that has some threading at the end of it is going to go through it and mount to the frame. That is going to use a compressive force against the clamp and the frame to be able to keep the clamp in place. This is the actual handle. This figure shows that the forces are the largest at the point where the screw connects the clamp to the frame of the saw, and this is just the bottom portion, for example. This next figure represents the factors of safety for the entire clamp system and shows that the minimum factor of safety is 11 for the clamp, indicating that it is not going to fail in static conditions. This figure also shows that the forces are the highest at the sides of the screw, where the bending moment is present from the clamp mechanism. This figure represents the factors of safety for the screw holding the clamp system and shows that the minimum factor of safety is 2.6, indicating it is not going to fail in static conditions. After we had run some tests in SolidWorks, this figure shows that the results from running a fatigue test on the screw for 10,000 repetitions, the results show that the stresses in the part result in no damage to the part, indicating infinite life.
The next time you reach for a sketchy manual saw and think, it'll be fine, choose our automatic miter saw system because your time, your materials, and your fingers are worth protecting.
Hey, I still need another board over here.
Okay.